So good morning again, ladies and gentlemen. This is lesson part 2, if you will, on simplifying rational expressions. And today we're going to look at example 1 from our handout. As you can see from the chalkboard, again, some of you might have to pause the video, but obviously, or if you look at the handout that you have already in front of you, is example 1 of our rational expressions handout that we have. Question A we're going to do together. We have x over 2x squared minus 4x. And that's our first one, really easy and nice and light. And if you can see from the rules, hopefully if the camera catches it, the rules for simplifying rational expressions, they're 3 easy things. Really easy. One more time, factor everything. That means the numerator and denominator. So let's just take a look at this question over here. The numerator, we can't factor it because it's x. But the denominator is 2x squared minus 4x. So I think everyone agrees there's a GCF here of 2x. What are we going to be left with? X minus 2. And that was the second step. Right? Everyone agree? Here is now, before we start simplifying, we state restrictions. Some students would argue with me, why can't we just do it at the end? We don't do it at the end because always it's for the original question that we're concerned about. Now I might be off screen in the video, but hopefully you can hear me. Hopefully you can catch it. So I'll just do the first one. The restrictions are, I'll use orange chalk. X cannot equal 0, that's because of this one. And x minus 2, so the other one is 2. Those are the only 2 restrictions. But now, we start simplifying. What does that really mean? These are fractions now. So whatever you see in the numerator denominator, we can start dividing out. We use my red chalk. This x divided by this x. Notice when you start dividing, just to help everyone out, x divided by x is equal to 1, not 0. I call it dividing up. If you get other teachers, they might say canceling. I don't like saying canceling because canceling really means to get 0 when you cancel. Like if you remember in grade 10, elimination method is eliminating by adding or subtracting. That's canceling. Like if you want to eliminate Mr. Chen, that becomes 0, becomes nothing, right? Anyways, so these are 1s. And that's it. That's all we have to simplify. I know it looks messy. Our final answer is 1 over 2 times x minus 2. And that is the answer we're looking for. Let's pause here for a second. Any questions about simplifying? Any questions at all from the class? Again, if you do this wrong, if you simplify first before you start factoring, or stating, let's start first. If you simplified and before you stated restrictions, some of you can say, but Mr. Chen, this answer, there's only 1 restriction. It should only be 2. That's not a big deal. However, in the original question, this is x was a problem, right? Any questions at all? Question B. We have 3y minus 2x over 4x minus 6y. This is an ugly one. So numerator, I think, let's just box that out of the way so we can see it a little bit better. There's nothing we can do with that numerator. 4x minus 6y. Any volunteer have an idea? Mackenzie?
2 and then 2x minus 3y.
Thank you. Now this one is actually suspicious, but you factored correctly. The reason why this question, I rarely give this one question out. Again, if you were in the regular system of a school, this is fine, and you would see this on a test. This one is probably a little tricky. You did it right, so let's get to step 2 now. State restrictions. Any volunteer want to state the restriction for this one? This one's a little tricky, but I think you guys are understanding. Simone, you want to try?
Yeah, so for the 2, it's x doesn't equal to 0, so it's 0.
Okay, so you gotta be careful there, right? Let's take a look at this one more time, ladies and gentlemen. This one's really tricky, so don't feel bad, and that's okay. In this factor, which you did nicely, by the way, 2x minus 3y, this is a problem. There's our variables here. So one more time, I'll use yellow chalk if that's okay. I take that whole factor, and I don't make it equal to 0. This one's trickier than this one. Notice this is a 2, right? You did this right. Way to go. Right? It's not like this one. It's sort of like, but it's not really. There's no other variable to take out, right? The GCF in this case was a whole number. So you have two choices. Most students will solve for x because that's what you've been trained to. But technically you could also solve for y. So watch what I'm gonna do when I solve for x. I'm gonna add 3y to both sides. I know that some of you are confused. It's okay, just ask me later. But most students will do this and then divide by 2. And ladies and gentlemen, this is your restriction. X can never be 3y over 2. If it ever was, this expression would go to 0. And then we cannot divide by 0. We talked about that online. When we divide by 0, that causes us immense problems. Let's just pause here for a second. Any questions right now? If you wanted to solve for y, we'll use pink chalk. That's okay too. But ladies and gentlemen, you only have to solve for once, because that's the answer. But if you wanted to solve for y, just to talk about it, subtract 2x to both sides. Okay, Mr. John. So I get negative 2x there. And then divide both sides by negative 3. And y can't be 2/3 of x. If it ever was positive 2/3 x, this expression would go to 0. Mackenzie again.
On a test, do we only have to solve for one variable?
That is correct. Most students, when you see, so that's why just be suspicious about this example B. And that's why I try to preference it when we started to do this example. So you notice I find this smaller handout that I gave you, the second one, it's actually a little bit easier. This one just ran, like, question A, what the hell, Chen? It just ramps up the difficulty like so much. But it's okay, I think you guys can manage, right? And that's why I'm just trying to show you. This one's a little tricky. I'd just like to rephrase what Mackenzie said. You only tend to solve for one of the variables. So when there's two variables, be suspicious. Simone, is that okay? Does that make more sense now?
Yeah.
What you saw? And it's, don't feel bad. Like, everyone saw that she said x can equal to 0. That's okay. That's why a lot of you realize you plug in 0 here, that'll go to 0. But 0 minus 3y, that's still 3y. Oh, 0 is not a restriction. Everyone understand? That's why a lot of you can check your answer. That's why I do ask you, take your time, go slow. Any questions still before we continue? This is, for such a small question, question B, it's taking a long time to digest. And that's why in some sense, this is easier to be in class rather than being at home, because it flies by so fast. Any questions still? If you can't see, Annika, if you can't see it, feel free to stand up or ask me to make it larger, okay? Because I know your spot is a little, the angle's really tough. So back to this one. Why did I say this question was a little interesting? Well, let's take a look at this question a little bit further. That's 3y minus 2x in the numerator. And that's 2x minus 3y in the denominator. And it looks like, Mr. Trump, you can't divide out. They're not the same, because subtraction is not commutative. However, just to show you something,
Yeah.
you want to say it?
Wouldn't you have to factor out the negative as well?
Yeah, I would actually do that. Now, what our classmates said is that there's a negative here that is suspicious, and most students, to be honest with me, most students will take the numerator part. I tend not to factor out a negative in the denominator. The reason why, again, it's a little easier to do over here, and I'll do this in blue chalk. So don't feel bad if you didn't see it initially, right? I'm just gonna do this in blue chalk. That's the numerator running green. I'm gonna factor out a negative 1. Watch what happens when I factor out a negative 1. I get negative 3y plus 2x. Now some saying, Mr. Chen, this doesn't look like this, but although subtraction is not commutative, meaning, I'll do this off to the side so the camera doesn't catch it. Addition is commutative. You can do that. So what I'm trying to share with you, ladies and gentlemen, don't get me wrong, when Mackenzie factored for us, it wasn't obvious right away. That's why we did this right. However, when we factor out a negative 1 and rearrange this, that's the positive 2x. That's minus 3y. So let's just take an extra step just to show that. Let's pause here for a second. Any questions still? Notice You can't just start crossing things out. And I'll explain that in our question C in a moment. And it's okay if you're slightly confused. That's why you should ask me stuff. But a lot of you realize, and I think I was using red chalk, let's start dividing things out. Does anyone see anything that we can divide up? I think we can now, right? This divides up this. So what's our answer? -1/2. One more time. If you forget to follow step 2, stating restrictions after you've factored, you're going to have a bad time. Because you say, Mr. Chen, this answer has no restrictions. There always was one. This. Or this. But you don't get it just like a classmate asked. It's okay. Any questions so far? Any questions on? Oh,
Would we get it wrong if we factor the negative from the denominator?
it would not be incorrect. We get this answer, right? Nice answer. Nice question. So you would get this. 1/-2. Notice these are exactly the same. Or even this. All three of these are fine. But please make sure that you realize that this is not the same. Because this is this. That is why fractions were so important when we taught you in grade 9. It was so important. And hopefully you're realizing what we're doing. I like my negatives in the numerator. That's why I tend to do it this way. Again, and the stuff in blue, one more time, just to go back a couple steps for the class. The blue part, we didn't realize it, and that's why you should have been suspicious. The question B was actually a hard question. We should have actually, in my opinion, we should have factored a -1 in the numerator. Don't feel bad. It wasn't your fault. It didn't look like there was. We factored the denominator, which is what we got nicely. And then the restriction in yellow or in pink. Notice you do not need to do both. Just choose one. Most students will, X tends to be the one that's easier for a lot of students. X cannot equal 3y, or 3y/2, or 3/2 y. And finally, it simplifies further. Any questions still before we get to question C? I am going to raise question D, and I'll move that question C over here. So even though the people at home are watching this video, but I'm going to use this one as a wrong answer. So I don't recommend you copy this one out. This is what, unfortunately, people haven't been reading their notes or trying in class or even dinner. They're going to do it like this maybe. They see the question x² minus 3x minus 10 over x² plus 8x plus 15. Notice what they're going to do? They'll say, hey, let's cross this out, cross this out. What are you talking about, Jeff? I can do this. Hey, look at that. -3. Hey, look, hey. That's 4. That's 8. That's 5. Done. 5/4. Done, Jeff. This is wrong. Okay? The reason why you can't divide out or cancel is because there are terms here. Now, some students say, but Mr. Chen, you have terms here. What are you talking about? Question B. But this is a factor that's been all multiplication. Right? When crossing out and dividing out, you can only do it when it's all multiplication. Okay? So that's why I'm going to erase this because I'm worried that someone's going to do it. But inevitably, it tends to happen. So don't do that. And to give you the proof, seriously, 1 plus 2 over 4, if you were to do this, notice I decided to use real numbers. If you divide that 2 with 1 and this to be 2, then you do the math. 1 plus 1 is 2 over 2, which is 1. That's incorrect. Because a lot of you know the original question, 1 plus 2 over 4, that's 3 over 4. 3/4 is not the same thing as 1. That'd be a neat trick if it was. Right? So that's why I'm trying to show you. You can't just cross things out. However, a lot of you know, factor everything. Any volunteer for question C want to factor the numerator for me from the class? x² minus 3x minus 10. It is factorable. Simone?
Yeah, so we got x plus 5 with a bracket x plus 5 and then bracket x minus 2.
I think you're partially correct. Let me just make sure I copied the question. It is plus 3x. So I made the mistake. It's not you, it's me. Because you did it right. Because so I have it. Any questions so far? Denominator, different volunteer? The x² plus 8x plus 15? Different volunteer? Sure, Mackenzie.
X plus 3, x plus 5.
I actually like that you said it that way. Thank you so much. Again, it does not matter the order. Everyone agrees? Before we continue, everyone okay with step 1? Factor everything? Anyone still in trouble? It's okay. Any questions so far? Different volunteers, step 2. State the restrictions. Really easy. Athena, you want to try?
Negative 3 and negative 5.
-3 and -5 are the restrictions. Everyone okay with that? That's the new big idea. Don't get me wrong. I think a lot of you know what I'm trying to do. Any question about stating restrictions from the class? Anyone want to tell me? Is there anything we can cross? If there's not, then that's the answer. We just stop here, right? But now we have to go. Vanessa?
The x plus 5.
The x plus 5s. Red chalk there, red chalk here. So what's our final answer, Vanessa? If you don't mind trying to say it.
X minus 2 over x plus 3.
Nicely said. X minus 2 over x plus 3. And this is the answer. This is the answer. Everyone okay? Any questions? Notice, if you start crossing these out, these x's, and you've done all, you lose marks. You lose marks. Mackenzie,
So if the x's are in the brackets, you can't.
if it's all multiplication, this is subtraction, this is addition.
Right.
That's
okay.
why, one more time for this one, I left this on the chalkboard. If you see the x's all by itself, this is all multiplication. 2 times x times this x minus 2. This expression. Notice I didn't cross out these x's. You can't do that because this is in brackets. And it's being subtracted. And notice, let's pretend if this was 2 over 2 times x minus 2 like this. This is not the question. Then I can't do these two. I can only do these.
Okay.
Does that make sense?
Yeah.
And it's okay. You'll have to figure it out when you're doing your work at home. Any questions still before we get to question D? Question D? You know what? Okay, well we'll do it. We should do it. I'll erase this question A and B. Okay. I'll stop the video in a moment. Do that question C on the chalkboard still. And question C is typical. This tends to be the straightforward one where we have simplifying, factoring, stating restrictions. It's the good big idea, right? Question D as follows. 2y squared minus 1 minus 15 over 4y squared minus 13y plus 3. Any volunteer from the class would like to factor this for Mr. Chen, just to help me out, because I actually don't know the answer. I'm always doing this. Athena, you want to try?
Y minus 3 to 1 plus 5.
Y minus 3. I'm sorry?
2y plus 5.
Let's just check our work if that's okay. Y and that. 6. Yeah, it looks good. And denominator, if you don't mind anything? Or if you did, that's okay too.
4y minus 1.
4y minus 1.
Y minus 3.
That's good. Anyone disagree from the class? Anyone disagree? And again, if you're watching this at home, I'm off screen. Hopefully you can still hear me. Hopefully it's recorded. Is it recorded?
Yeah.
Yeah, 17. You're very upset. I'm not going to do it again. Any questions about this factor? That's the hardest part. Once you get the factor, I think a lot of you know the stating restrictions, if it's a factor form, is easy. Someone new perhaps? Impress me? Maybe someone that hasn't said anything at all yet? I am trying. I do check the participation rate. Do we have a question? Anyone want to try for this one? Nora? Sure. Wait, no.
I just changed my mind.
Okay. Well, for this one? Genevieve, you want to try for this one? Why am I saying no pressure? We get it right with yours.
We cancel minus 3.
Okay, you're jumping. You are correct,
Okay.
but we have to state the restrictions. Someone on
Oh, sorry. Okay. Then it would be couldn't equal 3 and it couldn't equal negative 1.
So close. You're so close. It's good. I'd like to try. It's all good. Thank you so much for trying. So when you add 1 to both sides, and don't feel bad when you see it like this. It's a little tricky, but long story short, a lot of you already know it's going to be the opposite side. When you add 1 and then divide by 4. So that's 1. And it's very similar to this. So notice if this is negative and you got this one easy, nicely done. This tends to be easier, right? Because when that's 3, 3 minus 3, that's 0. That's positive 3, that's negative 3. Nicely done. You just any questions so far? And then we finish it off that Genevieve said. She said that this 1 minus 3 divides out this 1 minus 3. And then our final answer, I think, is this. 2y plus 5 over 4y minus 1.
Would we have to show our work with
No.
our thinking? No?
A lot of students can do that here. Sometimes when it's a little trickier though, some students will do it off to the side.
But we won't be marked on it.
It's just this part that I'm marking. But again, I said this, I think, online. If you say, Mr. Chen, you old. You won't know. I'll put -3 and then 0 and then I don't know. I see a 4 there, and maybe I see that 5. I'll just do. I don't know. I'm just trying to say crazy. If you write this out, you're losing marks because that just means you don't know what to stop. You're just trying to guess. It's like meeting someone special, right? And you forget their name, like, oh, you have a bad time. Rather than, hot guy, hot girl, right? Like, it's embarrassing. That's why you gotta pretend to look at their driver's license. Can I call you? Just kidding. Don't do that. Any questions so far? I'm gonna pause this now.